So let's take a look at Achieve section 310, number 6. These are the related rates problems, and there's a lot of words. I recopied the words from the problem, and the words have meaning, and we need to make sure we comprehend and understand them, plus all the little extra details that they give in the parentheses down here. So there's a lot going on. Okay, so this problem we have a 5M, what's M? Meters, okay? 5 meter long ladder, basically, right? It leans against a wall. The bottom of the ladder is 1.6 meters from the wall at t equals 0 seconds. That's abbreviation, right? And it's the bottom of that ladder will slide away from the wall at a rate of 0.4 meters per second, okay? Again, don't over analyze this problem. We're assuming there's no friction. It's a crazy situation. The ladder's just, think of it as almost being on rollers there. It'd be a ridiculous setup for a ladder, but this thing is going to move at that rate. And what we're asked to find is the velocity, and the velocity, remember, is a rate of change. All right, so we're looking to relate this rate to the rate that we know, this unknown rate. That's what related rates problems are all about. So we're going to find the velocity of the top of the ladder. So we know what the bottom of the ladder is doing. We need to know what the top of the ladder, as it slides down the wall, right? It's leaning against the wall at time t equal 2 seconds here. It does have a parentheses, take the direction upwards as positive. Okay, so basically that means, with this ladder bottom going away from the wall, the top of the ladder must be what? Sliding down the wall. So when we're looking for the velocity, you should be automatically thinking, hey, my velocity should be negative. Okay, I'll also set that up within the problem, and you'll see how we will get a negative answer from that as well. Also, we're going to round our final answer to 3 decimal places. Okay, so with all these problems, well, the majority of them, vast majority of them, you need to draw a picture. You need to draw a picture showing what's going on and label any variables in the problem. Okay, so here is my picture. And here's my wall, and here's the ground, and we're going to assume a right angle there. Do not complicate things by saying, what if it's not a right angle? That's going to make things more difficult. So it's not stated explicitly in the problem, but we're going to assume that this wall is, again, 90 degrees with the ground, and that's what you should do, unless told otherwise. The ladder here, right, this is the ladder. It's 5 meters long. And so here's the bottom of the ladder, right, and it's going to be moving away from the wall at the rate in this particular problem was 0.4 meters per second. Again, your numbers could be slightly different than this, but essentially the same idea. So that value of x is getting bigger. So the rate, and notice I labeled this as x. They didn't tell you this in the problem, and you should do this in your support on your homework and on the test. So you want to show, these variable quantities that we are going to relate, and then we're going to differentiate that relationship to get the related rates equation. So I'm going to let x be the distance that the bottom of the ladder is from the wall, and y to be the distance that the top of the ladder is, or the height that the top of the ladder is above the ground as it slides down the wall. Okay, so obviously as the bottom goes to the right, the top here is going to have to slide down this way. Okay. All right, so what are we given? What rate are we given? Well, we're told that the rate of change of x with respect to time is 0.4 meters per second, same as the velocity of that bottom of the ladder, right? So that's dx dt, right? So there's the power of the derivative. The derivative gives us the rate of change. So dx dt means the rate of change of x with respect to time, and that's given to be 0.4 meters per second. What we're asked to find is, right, the velocity of the top of the ladder, right? So what's the velocity of the top of the ladder? Well, that's just going to be the rate of change of this distance, y, right? So that's dy dt. So we're going to find dy dt at what? At t equal 2 seconds. Okay. So first of all, you want to get an equation that relates your variables of interest. So hopefully you see in here, we have a right triangle. I want to relate x and y together. And so the obvious choice is the Pythagorean theorem, right? The square of this side of the right triangle plus the square of the other side is equal to the square of the hypotenuse, 5 squared, which is of course 25. So there's your equation that you start with, and then we differentiate with respect to time. Now on the right-hand side, 25 is a constant. Obviously, the derivative is 0. But here, x and y are not functions that are not constants, right? They're changing, right? And so when we take the derivative with respect to t of x squared, it's chain rule. The outer function is x squared. The inner function is x. So the derivative of the outer function is 2x times what? The derivative of the inner function, dx dt. So you're always going to have that, right? You're going to take the derivative of 2x, and then you're always going to tag on this, dx dt. Okay, notice it's with respect to t, not with respect to x. Same thing with y squared. Derivative there is going to be 2y dy dt, right, by the chain rule. So, and this right here is our related rates equation. This is the equation that relates the rates of change. Notice that we know the dx dt, right? That's the given one, and we're asked to find dy dt. Okay, now we do have x and y in this equation, so we're going to have to find those values at the time t equal 2 seconds. That's what I'm doing over here. But what I'll go ahead do here is I'm just going to solve for dy dt. I'm going to subtract the 2x dx dt here, and then divide by 2y. 2 divided by 2 is 1. I just get negative x divided by y times dx dt. So there's a nice relationship. Now I can just plug in what I know for x, y, and dx dt to find dy dt. Well, I know dx dt is 0.4 meters per second, but what about x and y? Well, so there's a bit of information we haven't used yet. It tells us that at time t equals 0 seconds, that the ladder is 1.6 meters from the wall that was given in the problem, right? Right, at the bottom of the ladder is 1.6 meters from the wall at time t equals 0 seconds. That means the value of x is 1.6 meters at time 0 seconds. Okay, well, 2 seconds later, right, we're starting at 0 seconds. 2 seconds later at time t equals 2 seconds, what is the value of x? Where is the bottom of the ladder now? Well, it's moving at 0.4 meters per second. So if I multiply 2 seconds times 0.4 meters per second, notice my units of seconds will cancel. I get meters, right? So in other words, in 2 seconds, it will travel 0.8 meters, right? If it's traveling 0.4 meters per second. So if I add that 0.8 to the 1.6, I see that x is 2.4 meters at time t equals 2. Okay, so I know what x is. Now what's the value of y? Well, remember we have this relationship. At any point in time, we have a right triangle. So if I plug in x as 2.4, I can solve this for y. And that's what I'm doing here. I get y squared is 19.24, and then I take the square root. I'm not going to approximate this right now. Leave that for the very end. Don't round off any intermediate results always. You want to round off the final answer to 3 decimal places, but don't round this off yet. Okay, so now I'm just going to plug in dy dt is negative x, and the value of x is 2.4, divided by y. The value of y was the square root of 19.24 times dx dt, and remember that was 0.4 meters per second. Okay, so if you use your calculator to carefully multiply that all out, and I've done that here just to show the proof right here. There's my 2.4 times 0.4 divided by the square root of 19.24. Of course, it's negative. Don't forget the negative sign. And that's important, right? We already said from the beginning, we knew the velocity would be negative. They were emphasizing. That's why I think they gave you that, little parenthetical statement, take the direction upwards as positive. So we're going downward, it's going to be negative. But that negative also comes from the fact that y is decreasing. So we expect dy dt to be negative because y is getting smaller. Okay, so the actual speed is 0.219 meters per second at that instant for the top of the ladder. The negative sign simply indicating that it's going downward. In Achieve, you just put the number in the box. They already have the units you'll see off to the side. And so this is the way you do this problem. All these problems, again, are challenging, but you want to, these should be interesting to you. These should be fun to do, sort of like solving problems, solving little puzzles. They're very contrived, obviously. We're neglecting friction, et cetera, but the very basics and fundamentals are very important for being able to apply the derivative to rates of change problems. Okay, I hope this helps, and let me know if you have other questions.